going to be simplifying expressions with rational exponents, and what you need to understand is if you have x to the 1/2, or let's say you have x to the 1/3, or let's say you have x to the 1/4, those are just roots. So x to the 1/2 is the square root of x. X to the 1/3 is just the same thing as saying cube root of x. And x to the 1/4 is the same thing as saying the fourth root of x. Okay, we have 216 raised to the power 1/3, and it is the cube root of 216, and we know that it's going to be 6 to the 3rd. And remember what we said in our last lesson, the exponent and the root kind of like cancel each other. So the cube root of 6 to the 3rd is just 6. For b, you have 7 raised to the 1/2 times 7 raised to the 1/2. So what you have is you have the square root of 7 times the square root of 7, which is 7 times 7 is 7 squared, and it's also equal to the square root of 49. And we know that the square root of 49 and the square root of 7 squared is going to be 7. For example C, we have 5 to the 1/4 times 125 to the 1/4, which gives you the fourth root of 5 times the fourth root of 125. So let me rewrite this. So we have the fourth root of 5 times the fourth root. Now you notice that 125 is the same thing as saying 5 to the 3rd power. So you have the fourth root of 5 to the 4th power. And remember our last lesson, the root and the exponent kind of cancel. So the fourth root of 5 to the 4th is 5. Now if I go to my calculator and I calculate 5 to the 4th power, that's 625. And if I go over here to control Hilltop, the index is 4, the root is 4, and you're going to write 625, enter, and it is 5. We will now convert from exponential to radical form, but I need to tell you a rule. We know that a to the 1 over n is going to be the n root of a. And let's say that you have a number that's in the numerator. Let's say you have some number m over n. Then it's going to be the nth root, and it's going to be a raised to the power m. So in other words, the m will be the power for a, and n is a root. So if you want to think about this, the m is a power and the n is a root. So for example, a, we have x to the power 3 divided by 7, right? So 7 is the root. We have x, and x is going to be raised to the 3rd power. We are going to convert y to the -3 power. So let me write, we have y to the -3.5 power. Let me write it as a fraction. We have y raised to the -7 over 2. Why 7 over 2? Because 7 over 2 is 3.5. Remember, the negative means I'm going to get the reciprocal. So you have 1 over y to the 7 over 2. So what we have here is we have y to the 7th, and then you get the square root. Now what you need to do is simplify. So you have 1 over square root. You have y to the 2nd, y to the 2nd, y to the 2nd, times y. Because it's 2 plus 2 plus 2, which gives you y to the 6th, plus the next y, which is y to the 7th. So you have 1 over y cubed times the square root of y. We normally don't like to leave it square root of y in the denominator. So you multiply times the square root of y. You multiply times the square root of y. So you have the square root of y over square root of y times square root of y is going to be y squared, so it's going to be y to the fourth. Okay, we're going to convert the square root of a to the fifth. So we know that the index is 2. We have a to the fifth. The index is 2, so it's 1/2, right? So this is going to be the same as a raised to the 5/2. The next example is the fifth root of b, and it's raised to the third power. So we have the fifth root. So we have the base is b. We know that it's a root, so it's going to be in the denominator, 5, and of course the power is 3. So what you have to remember is the numerator is a power, and the 5 will be the root. So 5 is the power, and then the 2 is the root. Using rational exponents, planetary motion, Kepler's third law of orbital motion, shows how you can approximate the period it takes the planet to complete one orbit of the sun. Use the function p equals d to the power 3/2, where d is the distance of the planet to the sun in astronomical units. How many Earth years does it take for Mars to orbit the sun? So for Mars to the sun, it tells you it's 1.52. So that's what you're going to have to substitute into d, which I did here. We have 1.52 raised to the power 3/2. You're going to press enter, and your answer is approximately 1.87 Earth years. What we have to do here is we have to combine these two radicals, and we know that the numerator, that radical is raised to the the fourth root, and this radical we have the root of 8. So we rewrite it. The fourth root of x to the third and the eighth root of x to the second, we're going to be dividing it, and we're going to use our power rules. So we know that if we have x to the third 3/4 power divided by x to the 2/8 power, then if we look at our exponents, we have 3 over 4 minus 2 over 8. And what you can do, you can use your calculator. 3 divided by 4 minus 2 over 8. 0.5, isn't that a half? So that's 1/2. So what this is going to be, it's going to be x to the power 1/2, which is going to be the square root of x. I'm going to work out 16 raised to the negative 2/5, and I'm going to do it, I'm going to show you the steps again. So remember that we have 16, and it's raised to the negative 2/5 power, which is the same thing as saying 16 raised to the negative 5 over 2. Remember that 16 can be rewritten as 2 to the power 4. And of course we have negative 5 over 2 here as a power. And you know your power rules. You know that if you have a power raised to a power, you can multiply. 4 times negative 5 is negative 20 divided by 2. So you have 2 raised to the power negative 10. Because what's negative 20 divided by 2? It's negative 10. And then, since it's a negative, you do the reciprocal. which is 2 to the 10th, which gives you 1 over 1024. When you evaluate 2 to the 10th, it's 1024.